Ooh, baby, you know I'm stuck on you. Ooh, baby, you know I'm stuck on glue. Ooh, baby, you know I'm stuck on you. Ooh, baby, you know I'm stuck like glue.
In many of today's circuit board designs, surface mount chip components are attached to the bottom side of the board. Through-hole components, as well as the larger surface mount components, are attached to the top side of the board. When surface mount and through-hole components are combined like this, we call the board a mixed technology assembly. When there are just surface mount components on both sides of the board, we have a surface mount assembly. With mixed technology assemblies, bottom side surface mount components require adhesive application so they don't fall off during the subsequent component placement and wave soldering operations. For double-sided surface mount assemblies, the surface tension of the solder is enough to hold on bottom side chip components during top side reflow. But if there are larger components on the bottom side, there won't be enough surface tension from the solder to hold them on during top side reflow. These types of components will also require adhesive application. This video will examine the surface mount adhesive application process. You'll be introduced to the two primary methods of adhesive application: dispensing and stencil printing. And we'll take a look at the characteristics of the adhesive itself. During the remainder of the program, we'll provide details on common setup procedures, system operation, troubleshooting, and preventive maintenance for both dispensing and printing of adhesives. Before we start, let's review a typical assembly process for double-sided mixed technology boards. This example will use the dispensing method for applying adhesives. We begin with the top side of the circuit board, where the larger surface mount components will be attached. First, solder paste is printed onto the lands of the circuit board using a stencil and squeegee. Next, the components are automatically placed on the board so that the leads are accurately aligned to the solder paste covered lands. Then the heat from the reflow oven activates the flux in the solder paste and melts the paste to join the lands and the component leads. Now we're ready to begin the surface mount assembly operation for the bottom side of the board. The first step is to apply the adhesive dots in the precise locations where the surface mount chip components will be placed. Notice how these dots of adhesive are dispensed between the lands rather than on the land itself. If the adhesive was placed on the land, the component wouldn't be able to be reliably soldered to the land. That's because the adhesive would block the solder. After all of the adhesive dots are applied, the components are positioned, typically using a high-speed chip shooter. The next step is to cure the adhesive in an oven. Curing allows the adhesive to achieve its full strength. After this step is completed, the components are securely attached to the bottom of the board. These connections aren't as strong as solder joints, therefore it's important to handle the board carefully. At this point, we begin the through-hole component assembly sequence. Automatic insertion equipment is used to insert the through-hole component leads through the corresponding holes on the top side of the board. These leads are automatically cut and clinched from the bottom side. Next, through-hole components requiring hand insertion are added to the board. The fully assembled board is now passed over a wave of molten solder. The solder wicks up the holes to solder the leads of the through-hole components. The chip components that are glued to the bottom of the board are also soldered at this time. Wave soldering completes the assembly process for this double-sided mixed technology assembly. Now that you understand the purpose of adhesive on bottom side surface mount components, let's take a look at the two primary methods for applying the adhesive. Most manufacturers apply adhesive by dispensing. In this method, adhesive is applied to a circuit board by a nozzle or needle mounted on an XY positioning system. For each component on the board, an appropriate adhesive dot pattern is dispensed according to the component's size and land pattern, or where it will be placed. There are many different types of mechanisms used to force the adhesive through the nozzle and onto the circuit board. The three most common are time pressure or air over dispensing, the Archimedes metering valve, and the piston positive displacement pump. In time pressure dispensing, the nozzle is connected to the adhesive syringe, either directly or by a short cylindrical channel. High pressure air, typically 20 to 40 pounds per square inch or psi, is pulsed on the back of the syringe for a programmable period of time. This air pressure forces the adhesive through the nozzle and onto the circuit board. These dispensers use a vision system to provide dot size control. This is done by comparing the measured dot size with a reference dot size and adjusting the air pressure accordingly. The vision system is required because the dot size varies as the amount of adhesive remaining in the supply syringe changes. As the syringe empties, more air pressure is required to compress the increasing volume of air in the syringe. The Archimedes metering valve uses an Archimedes screw to meter the adhesive onto the circuit board. A constant low-pressure air supply of 10 to 20 psi feeds the adhesive from the supply syringe into the screw. The screw rotates for a programmable rotation distance, forcing the adhesive through the nozzle. The last type of pump we'll discuss is the piston pump. In this system, adhesive is displaced by the action of a reciprocating piston. The adhesive is fed into the piston by a low-pressure air supply. The volume of adhesive is dependent only on the piston's stroke length and diameter. The stroke length can be changed through a mechanical adjustment on the pump. Also, the frequency of piston cycles is not dependent on stroke lengths. This means that dots of small and large volumes are dispensed in the same amount of time. Your company may have one or more of these different types of dispensing systems. The important thing to understand are the general principles of adhesive dispensing. All of these dispensing systems share the same basic set of parameters that determine their performance. These include nozzle size, air pressure, and quantity of adhesive dispensed. Each system has advantages and disadvantages. For example, one type of system may be easier to clean, and another type may have better repeatability of dot size. Now let's examine the other primary method of applying adhesive. In the past few years, more and more companies have been investigating stencil printing of adhesives, especially in high throughput situations. The big advantage of stencil printing over dispensing is speed. Today's ultra-high-speed dispensers have a maximum rate of 100,000 dots per hour under ideal conditions. Stencil printers can well exceed this rate under normal conditions. One disadvantage of adhesive printing is flexibility. Every time a board population is changed, a new stencil is required. Another disadvantage is that cleaning small stencil apertures is more difficult than cleaning nozzles. When stencils are used to print solder paste, the height of the paste is roughly equal to the stencil's thickness. With adhesives, the viscosity or thickness of the material and the size of the aperture or opening in the stencil determines the shape of the adhesive dot being printed. This is because the adhesive normally doesn't release completely from the stencil aperture. Any stencil printer capable of printing solder paste for fine-pitch surface mount components can be used for adhesive printing. The most important aspect of the printer is its ability to form a programmable snap-off or printing gap between the board and stencil. The printer should also have a programmable controlled separation of stencil and substrate after the printing stroke. Our final topic for this introductory section is the adhesive. Different types of adhesives will be used depending on whether you're dispensing or stencil printing. Adhesives are made of ceramic fillers, epoxy, and a hardener. They may cause irritation to the skin. It's important to handle the adhesives properly and to wear protective clothing. Adhesives have several enemies. Heat is one. This is because the hardener is a solid powder, which melts at high temperature. When the adhesive is heated, the curing process starts and cannot be reversed. It is therefore important that the adhesive be kept cool. Another enemy of adhesives is age. There is a date code on the adhesive. Fresh adhesives dispense and print well. Only these should be used. Light can also harm adhesives. For example, sunlight can start the curing process. Adhesives should be stored in a cool, dry, dark location. Some adhesives designed for dispensing are sensitive to moisture in the environment. Printable adhesives are designed for exposure to room temperature and ambient humidity. Regardless of whether you're dispensing or printing adhesives, companies look to the adhesives for specific characteristics and criteria. There should be minimal volume variation from dot to dot. The green strength is the shear strength of the adhesive in the uncured state. High green strength is important to reduce component skewing during part placement. The adhesive bond should weaken at elevated temperatures to facilitate rework operations. The adhesive should also be easy to remove from misprinted boards in the uncured state. Finally, gull wing and J-leaded components have higher standoff and therefore require a higher viscosity adhesive. In this section, we'll examine some typical setup and operation procedures for dispensing the adhesive. Then we'll take a look at what's involved with troubleshooting errors and performing preventive maintenance. We'll assume you've come to work and there are boards requiring adhesive dispensing. These boards are usually accompanied by documentation that specifies the part number and revision letter of the assembly, the nozzle sizes and their spindle locations, the type of adhesive, board supports if required, and the program number to be loaded. The first step is to load the computer program. Next, we check that the tubes of adhesive, as well as the correct size nozzles, are properly located in the spindle locations. Make sure that all the nozzles are clean. You may need to change the adhesive and the nozzle sizes for a new run of assemblies. And sometimes the spindle may be empty. If this is the case, you'll need to drop in the tubes of adhesive and the correct size dispensing nozzles. Also, verify that the air pressure is set correctly and that the climate control is within proper limits. This is especially true on time pressure dispensing systems. At this point, we press the purge button. The pump will start to operate. Check that adhesive flows out the nozzles and that there's no blockage. Now set the rails to the size of the circuit board that will enter the machine. On some dispensers, this adjustment is done automatically. Then add appropriate board supports as required. This completes the dispenser setup procedures. In many companies, test dots are dispensed before and after each board is run. This is a good check to ensure that no dots are missing from any board. 3 to 5 of these test dots can be dispensed on a section of the board that doesn't contain circuitry, usually on the edge of the board. If the adhesive flows properly, both the before and after dots will have the correct size and shape. Now that everything is set up and working properly, let's watch the adhesive dispensing operation. First, a vision system verifies the proper position of the board within the machine using alignment marks, or what we call fiducials. Regardless of the type of dispensing system utilized, the adhesive is then pumped from the glue tube using air pressure. Some companies use push rods inside the syringe for consistent pressure. The computer controls the air pressure, the amount of adhesive dispensed, and the precise locations where the drops of adhesive are applied. As you can see, this process happens really fast. Now we'll look at it in slow motion so you can see it more clearly. Once the adhesive has been dispensed, the circuit board needs to be inspected. Your company should have their own inspection criteria that you will follow. An assembly drawing is used to verify that the dots are correctly placed between the lands and that they are the correct size. By turning the board to the side, you can easily see if the dot heights are consistent. The adhesive should never be dispensed across the lands. When adhesive gets on a land, there is likely to be an unreliable solder connection. Also, make sure you handle the boards only by the edges. It's very easy to smear the adhesive. If this happens, you'll have to clean the board and start the dispensing operation once again. If the dispensing has been done accurately, then the process is continued until all of the boards requiring adhesive application are completed. While the machine is dispensing the glue dots, it's important to stay alert for indications of nozzles clogging and the need for replenishing tubes of adhesive. To replace adhesive, simply remove the old tube and get a new one. To avoid introducing air into the process, force out a small amount of adhesive. Then roll the tube into place. If air gets into the tube, there will be inconsistencies and defects. It's also important to inspect every circuit board. Errors can be detected quickly and their causes remedied. At the conclusion of each job, it's critical that you clean the nozzles with an approved solvent. Using the wrong solvent can cause adhesive to cure in the nozzle. Cured adhesive inside nozzles is the main reason for nozzle failure. As you have seen, once a dispensing machine is properly set up, adhesive application pretty much happens automatically. Until something goes wrong. What do you do when the dots don't look the way they're supposed to? Let's examine some of the common problems and defects, along with typical approaches for troubleshooting. Stringing or tailing dots are by far the most common defect. Stringing and tailing simply means that the dot isn't formed perfectly. The dot either strings from dot to dot or droops into a tail. Here's an approach to troubleshooting a stringing or tailing dot problem. The first step might be to stop the dispenser and use a brush to clean the outside of the nozzle. Excess adhesive on the tip or bevel of the nozzle can cause these types of defects. If cleaning the outside of the nozzle doesn't improve the dot quality, remove the nozzle and clean the inside. Sometimes the inside gets clogged or a cured particle is hung up inside. Another step might be to check whether the nozzle is making proper contact. If the nozzle isn't coming all the way to the board, the dot can't be formed correctly. Finally, there can be a problem with the board supports. If the board is sagging, there will be inconsistent dots. Board supports should be added around the problem area. Stringing and tailing aren't always caused by machine-related parameters. Sometimes the surface condition of the circuit board, as well as the condition of the solder mask, can be the culprit. Another common defect in adhesive application is missing or inconsistent dots. You can take a similar approach in detecting and correcting this type of defect. The first things to check are whether the adhesive syringe is empty or very low, or whether the nozzle is clogged. In terms of the adhesive, verify that the tube is loaded correctly and is free of air. If there are air pockets, the syringe should be purged to force the air out. Check that the feed pressure is correct. If there is insufficient pressure, the pump starves intermittently and misses putting down a dot of glue. If this is the case, increase the air pressure. Then see if the problem is still there. You may need to replace the syringe if the stopper hangs up. You may also need to change the adhesive material itself if the shelf life was exceeded or if it was improperly stored. In terms of nozzles, again try cleaning the nozzle with a brush. If that doesn't work, remove the nozzle and clean the inside. Check the nozzle for excessive wear. Also, try cleaning the pump. If none of these steps change the result, replace the nozzle. Defects can also be caused by improper machine setup and/or calibration. All machine calibration should be performed by highly trained maintenance technicians. Not all problems are detected after the adhesive is dispensed. Sometimes later inspections will reveal missing components or insufficient solder that will relate back to problems with the adhesive. For example, when parts are missing and there is sufficient adhesive, the cause may be voids in the adhesive, which has reduced the area for component bonding. Voids occur when absorbed water is bubbled out of the adhesive during the curing process. A slow temperature ramp rate during curing can remedy this. Insufficient solder can be caused when an adhesive dot is inaccurately placed onto a land. That's why it's so important to carefully inspect the board prior to components being placed and soldered. Imagine all the rework that will be required if just one or two components on every board are missing or inadequately soldered. Our final topic for this section is cleanup and preventive maintenance. At the end of every shift, it's necessary to wipe down the surfaces of the dispensing machine with a lint-free cloth and an appropriate solvent, such as isopropyl alcohol. You'll want to remove any excess adhesive that is in contact with the surfaces of the machine. Also, it's critical to clean all of the nozzles so the adhesive doesn't harden and make them impossible to clean. Pumps are generally cleaned on a weekly or monthly basis. Your company and/or the machine manufacturer will have a specific schedule and procedure for cleaning the pumps. The remaining preventive maintenance is generally done by maintenance technicians. This includes performing periodic calibrations, checking and replacing air filters and air hoses, and greasing the bearings. Now let's take a look at what's involved in setting up a stencil printer for the application of adhesive. The variables for stencil printing of adhesives include the circuit board, the stencil, the adhesive, and the squeegee. Your documentation will specify the boards to be run, the program to be loaded, as well as the stencil, adhesive, and squeegees to be used. Before we go into the actual machine setup, let's briefly look at the stencil, adhesive, and squeegees. Stencils for adhesive printing are usually stainless steel or plastic. Stainless steel stencils have been used for years in solder paste printing. The openings are typically cut out by a laser. Recently, plastic stencils have been developed, specifically for adhesive printing. The advantages of plastic stencils reportedly include better gasketing due to their flexibility. This minimizes squeeze out of adhesive on the underside of the stencil and reduces the need for periodic cleaning of the stencil. The flexibility also enhances stencil release during snap-off or off-contact printing. The disadvantages of plastic stencils include only round apertures since the openings are drilled, and that metal squeegee blades can't be used since they'll damage the stencil. This means plastic stencils aren't as durable as their stainless steel counterparts. The next variable is the adhesive. As we said earlier, the main characteristic in an adhesive designed for stencil printing is that it must be designed for exposure to room temperature and ambient humidity. Beyond that, the requirements of the specific assembly will determine the adhesive that's selected. In terms of squeegee selection, the best adhesive printing results are typically seen with a hard polyurethane squeegee. Metal squeegees also provide accurate results. The squeegee pushes the adhesive down into the apertures and ensures full aperture fill and contact to the board. Now that you have an understanding of the variables involved in adhesive printing, let's take a look at a typical setup procedure. The first step is to use your documentation to load the correct computer program. The program contains the profile of the circuit board. It consists of the size of the board and all of the other parameters required for adhesive printing. These may include squeegee speed, pressure, downstop, board separation speed, and snap-off distance. We'll discuss these parameters in a minute. Once the computer program is loaded, use your documentation to select and install the squeegees. Next, load the stencil. Now dispense a bead of adhesive. Remember to verify that you're using the correct adhesive. At this time, add a board support block if required. The board needs to remain flat during the printing process. Now let's watch how the adhesive is printed. After the board is transported into the printer, the vision system reads the fiducials on both the circuit board and stencil. The system performs a series of calculations and makes necessary movements to position the stencil over the board in the best possible location for printing. The squeegee then strokes across the stencil, applying adhesive into the stencil openings onto the correct locations on the circuit board below. The amount of adhesive should be controlled so that it rolls in front of the squeegee. The adhesive application is then inspected by the operator. That's all there is to it. When the printing process has been implemented correctly, minimal process management is necessary. Basically, boards are loaded, the printing operation takes place, and the adhesive application is inspected. As we said earlier, the plastic stencils reportedly require very little cleaning. In contrast, stainless steel stencils require wiping periodically during the printing operation. Squeezing out of adhesive onto the underside of the stencil happens faster on metal stencils than plastic stencils. Also, the adhesive on the stencil needs to be replenished periodically. But as with any machinery, things do go wrong, meaning defective adhesive dots are produced and parameters need to be adjusted. Let's go back to the key printing parameters and examine how they can affect the printing. Remember, not all stencil printers require the setting of all these parameters. Snap-off is usually set at about 1 millimeter. Larger snap-off can help eliminate voids in adhesive application due to trapped air in the apertures. For lower viscosity adhesives that are similar in consistency to solder paste, contact printing or no snap-off can be used. The speed of the squeegee is also dependent on the viscosity of the adhesive. The lower the viscosity, the faster the printing. For example, a low viscosity adhesive may be printed at about 20 centimeters per second, and a high viscosity adhesive is printed at about 1.25 centimeters per second. Quite a difference. Printing the adhesive too slow or too fast can produce inconsistent dots. In terms of squeegee pressure, the higher the viscosity of the adhesive, the more pressure required to print properly. A rule of thumb is to have sufficient pressure so that the stencil is wiped clean of adhesive with each printing stroke. Squeegee downstop is generally set the same as it would be for solder paste printing. If the downstop is too low, the ability of the squeegee to wipe the stencil clean will be impaired. If the downstop is set too high, a coining or lifting of the stencil will be seen at the edge of the circuit board after several squeegee strokes. The separation of the board and stencil after the print stroke is a critical parameter. This is also dependent on adhesive viscosity. If this parameter is not set up correctly, stringing and/or inconsistent dot heights will result. Our last topic for adhesive printing is cleanup and preventive maintenance. When a production run comes to an end, the inevitable must happen: cleanup. It's important to note that common cleaning solvents, such as isopropyl alcohol, are not compatible with most printable adhesives. Your adhesive supply company will advise you on an appropriate solvent to use. The first step after a job is completed is to remove and properly dispose of all unconsumed materials. Next, clean and remove adhesive from the squeegees. It's important to check the squeegee blades for edge nicks. Also, look up into the squeegee clamp area of the print head to make sure no adhesive has gone up there. Then, thoroughly wipe down the stencil, making sure there is no adhesive left in the apertures. The adhesive will eventually cure at room temperature, making it more difficult to remove later. Now, check the tooling pins and board supports for any debris or adhesive. Clean these if necessary. Finally, wipe down the entire machine, removing any adhesive that may have gotten onto a surface. It's important to look inside the printer and see if any tools or materials have fallen inside during the job. While you're looking, check for frayed wire and worn belts. Any problems should be reported to maintenance. This program has presented the details of the adhesive application process for surface mount. We discussed the purpose of adhesive application and saw how it fits into the assembly process for double-sided mixed technology and surface mount circuit boards. You were also introduced to the two primary methods of adhesive application: and we took a look at the characteristics of the adhesive itself. Then we examined the details of setup, operation, troubleshooting, and preventive maintenance for both dispensing and printing of adhesives. Adhesive application is a critical step in surface mount assembly. If it's not done correctly, there can be missing components and/or unreliable solder joints. Both situations require expensive rework to remedy. Your careful attention to adhesive application makes a big difference in producing quality assemblies.